Hello everyone, my name is Wenjing. I'm the first author and the presenter of the research paper titled Gravity and Pressure Effects on MEMS Thermal Wind Sensors at the HV Sensors 2025 conference. The other authors are Sicun, Duan, Zhenxiang, Ming, Qing, and Qing-An, Huang. We are all from the School of Integrated Circuits, Southeast University, Nanjing, China. Unfortunately, due to the visa issue, I am unable to be present at the conference in person. But I am very pleased to present our work virtually, and I hope this presentation will provide valuable insights into our research. So, let's dive into the topic. MEMS thermal wind sensors are crucial for applications in fields like weather forecasting, agriculture, transportation, and air pollution control. These sensors are highly valued because of their small size, reliability, and low power consumption. However, one factor that often goes unnoticed is how environmental conditions, particularly gravity and atmospheric pressure, affect their performance. In this research, we aim to explore these effects and how they can be leveraged to improve sensor performance. Let me first explain what MEMS thermal wind sensors are. MEMS stands for Microelectromechanical Systems. Essentially, these sensors operate based on thermal convection. In simple terms, they measure wind speed by detecting the voltage required to maintain a consistent temperature difference between the sensor's chip and the surrounding airflow. The sensor consists of the small head surrounded by thermistors. When air flows over the heater, it creates an uneven temperature distribution. The sensor detects the resulting temperature differences and use that to calculate the wind speed. Additionally, the sensor chip is encapsulated in a protective package, and together with a constant temperature difference control circuit, it is installed into a three-dimensional prism shell, forming the complete sensor device. As I mentioned earlier, environmental factors like gravity and pressure can significantly influence their performance, and until now, these effects have not been fully explored. That's what the research aims to address. Let's now move on to the first major factor we studied, the gravity effects. One of the key findings of our work is that gravity has a significant impact on how MEMS thermal wind sensors perform. This impact depends largely on the sensor's orientation. To explain this further, we placed the sensor in a small wind tunnel and tested it in both upward and downward orientations. What we found is that the upward-facing sensor consistently requires more power to maintain the same temperature difference compared to the downward-facing sensor. The reason for this is related to neutral convection. Hot air rises up where cold air sinks. When the sensor faces downward, it obstructs the neutral upward flow of air, which allows heat to accumulate near the sensor surface, and thus less power is required. In contrast, when the sensor faces upward, heat escapes more easily, resulting in hair head loss and, therefore, a need for more power to maintain the same temperature difference. This finding is crucial for understanding how different orientations can influence sensor performance, especially in situations where sensor positioning can be controlled easily. Now, moving on the second factor we investigated, the pressure effects. We placed the sensor inside a sealed chamber, varied the atmospheric pressure, and recorded the required heating voltage. The atmospheric pressure was controlled to change from 10 pascal to 1 megapascal. The results were clear. As the atmospheric pressure increased, so did the required heating voltage. The underlying reason for this is that here atmospheric pressure increased, the molecular density of the air. As more air molecules are compressed into a given volume, more energy is needed to heat the same volume of gas. So, by fitting the experimental data, it was found that the heating voltage required by the sensor is proportional of the fourth power of the logarithm of atmospheric pressure. To summarize, our study sheds light on the critical effects of gravity and pressure on MEMS thermal wind sensors. By understanding how these factors influence sensor performance, we can significantly improve their accuracy and sensitivity, paving the way for more reliable measurement in a variety of applications, particularly those in specialized or extreme environments like Mars. Okay, the last section. This is reference and acknowledgement. Thank you very much for your attention. If you have any question, feel free to contact me via the email. I would be happy to answer them.